Hello, and welcome to ResearchPod. Thanks for listening and joining us today. In this episode, we're talking about a series of books written by Dr. Ofer Aluf from Israel, detailing the latest techniques for analyzing advanced electrical circuits. In his new book, Advanced Elements of Laser Circuits and Systems, Aluf expands on his academic history and past publications, offering expert insight into F-circuit analysis and laser applications. Over the course of his career, Dr. Aluf has developed cutting-edge innovations in a wide range of technologies, including computer chips, semiconductors, antennas, and high-powered lasers. He has also published numerous papers across multiple professional journals. One particular highlight of his research involves developing new ways to analyze the outputs of electrical circuits. In his series of books, Aluf has explored a number of concepts in circuit analysis, such as the use of opto-isolation, using light to send and receive signals between circuits, lasers, and microwave and radio frequency antennas. In each book, he focuses strongly on the practical and innovative applications of engineering and academic research, describing their scientific background at both basic and advanced levels. Furthermore, Aluf uses foundational mathematical theory as part of his explanations. Dr. Aluf's books are intended for electrical engineers, as well as those without an advanced mathematical understanding. Through his explanation of the key concepts, his books help them close the gap in their knowledge between electrical circuits and the latest techniques in mathematical analysis. The books are also useful to students at graduate level who are taking courses in physics, maths, and electronics, as well as researchers in physics. In 2012, Aluf published his first book, Opto-Isolation Circuits. In the book, he explores the analysis of systems which use light to transfer electrical signals between two isolated circuits. In real-life applications, this often involves a combination of an LED and a light-sensitive transistor, incorporating a semiconductor, which can alter the amount of current flowing through it, depending on the amount of light it receives. The ability to accurately analyze the outputs of opto-isolation circuits is highly relevant across a broad range of applications. These include circuit components which control, dissipate, and conserve the current flowing through them. In each case, Aluf begins with the fundamental mathematics required to describe basic opto-isolation circuits. From here, he builds up to the complex equations required to describe chaotic or nonlinear circuits. These are circuits whose outputs may appear to be completely random at first glance, but actually contain intricate underlying patterns intrinsically linked to the circuit's starting conditions. By closely linking his explanations to real engineering applications, Aluf enables each reader to fully understand the potential capabilities of opto-isolation circuit analysis, regardless of their previous level of expertise. Aluf's new book, Advanced Elements of Opto-Isolation Circuits, expands on the mathematical theory required to analyze these opto-isolation systems. In particular, he presents bifurcation theories of both linear and nonlinear circuits with opto-isolation elements. Bifurcation theories provide mathematical descriptions of situations where a small, smooth charge made to a circuit's parameters causes a sudden change in its overall output. These changes can take many different forms, each with its own unique mathematical description. The book also considers limit cycles of both linear and nonlinear circuits, describing how, over time, the relationship between two parameters of an oscillating circuit spirals into a more stable trajectory. By expanding on the principles introduced in his first book, Aluf helps his readers better understand the relevance of opto-isolation circuit analysis in real engineering applications. Moving on from these systems, Aluf's next book, Microwave RF Antennas and Circuits, was also published in 2017. In this book, he explores new concepts for analyzing circuits that are designed to produce electromagnetic waves with microwave and radio frequencies, RF. Each of these frequencies can be generated and received by antennas, which either convert alternating electric currents into electromagnetic waves or vice versa. Aluf applies the analysis of these circuits to different antenna designs, including dipoles, helices, and dual spiral coils, each of which employ different mechanisms for transmitting and receiving signals. Through his analytical approach, Aluf introduces advanced tools for optimizing these antennas. His methods are also relevant in a variety of other devices. These include transistors, which use electric fields to control the flow of current through semiconductor switches, diodes, which exploit the principles of quantum mechanics to enhance current flowing in a single direction, and cables designed to convey microwave frequency signals. Once again, starting from basic underlying equations and building up to their bifurcations and limit cycles, Aluf's book allows readers to understand the link between microwave and RF circuits and the advanced mathematical techniques required to analyze them. Circuit analysis isn't the Aluf's only area of expertise. In 2013, he published a book named Elements of Gradostat-Chemostat Two-Compartment Theory. This time, he investigated the interaction between bacteria and phage, the viruses that specifically target bacteria, when inside a device named a gradostat. This instrument generates a gradient in the concentration of nutrients in the surrounding environment, and the bacteria instinctively move along the gradient. Here, the same mathematical techniques can be used to find points of bifurcation in this biological system. This knowledge is immensely useful for operating bioreactors. It is important to remove the culture liquid at a steady rate to keep the culture volume constant. By understanding the behaviors of these microbes in more detail, operators could more easily maintain bacteria populations at suitable levels. This could potentially lead to applications including phage-driven treatments for bacterial diseases. In his latest book, Aluf introduces yet another concept in circuit analysis, this time based on laser elements. In Advanced Elements of Laser Circuits and Systems, the same mathematical foundations of bifurcations and limit cycles in both linear and nonlinear systems are used to describe the analysis of laser-generating circuits. His approach accounted for a certain time delay between circuit inputs and subsequent laser outputs, allowing operators to better predict the stability of their lasers based on circuit parameters. The book follows Aluf's previous approach by explaining the mathematical principles in parallel with their application in real-world scenarios, including solid-state lasers, which use orderly molecular lattices to stimulate photon emissions. These solid-state lasers include sapphire lasers, which are both highly turnable and also capable of generating ultra-short pulses. In addition, the techniques described are applicable to different types of gas laser, which produce light by discharging electric currents through a carefully mixed vapor, and even quantum cascade lasers, which exploit exotic quantum-scale interactions within semiconductor materials to emit photons at far infrared frequencies. With such a diverse range of applications, Aluf's book describes how his analysis concepts are appropriate for technologies such as circuity for MRI machines, which use strong magnetic fields to produce high-resolution images of hidden structures, including medical images. Moreover, these concepts could also be used to study plasma mirrors, which rapidly change their optical properties from almost perfectly transparent to highly reflective. By integrating these applications with mathematical equations and building up from the basic principles, Aluf, once again, aims to help researchers and engineers with a background in laser and plasma physics gain the knowledge required to analyze the laser circuits involved, even without a detailed understanding of their nonlinear dynamics. By explaining these advanced concepts at a level suitable for engineers, researchers, and students alike, Aluf's books will help expand the application of advanced electrical circuits alongside other complex phenomena which are affected by bifurcations and limit cycles. Equipped with a new analytical toolset, these readers may be inspired to push the boundaries of existing cutting-edge technologies even further. Thanks for listening. You can find advanced elements of laser circuits and systems available now from Springer, with links to the ebook in this episode's description. More on Dr. Aluf's publications are available via Amazon. And stay subscribed to ResearchPod for more of the latest science. See you again soon.